Hello and welcome to today's webinar in partnership with Greiner Packaging and Emmi, hosted by Packaging Europe. In today's webinar, we will delve into how to overcome the material gap in food packaging. My name is Elisabeth Skura. I'm the editor-at-large here at Packaging Europe. For those of you who are unfamiliar with Packaging Europe, we are the leading intelligence resource for packaging professionals around the world via our website, as well as online and in-person events such as the Sustainability Awards and Sustainable Packaging Summit. We deliver daily news content, authoritative comment and analysis, case studies, and high-profile interviews with leading industry players. And we set out to enable communication across the packaging value chain. So a bit more about today's webinar. By 2030, regulations like the packaging and packaging waste regulation will require a specific percentage of recycled material in food and non-food packaging. And while these requirements aim to advance the circular economy, they also pose significant challenges for the industry. And a major obstacle to fulfill these requirements is the limited availability of recycled material, especially for food-grade applications, making it difficult to align environmental goals with economic viability. So how can we overcome this pressing material shortage? Today, we will hopefully find some answers, and we will take a look at how big the material gap really is and examine the key challenges plastic packaging manufacturers face in bridging it. We'll also discuss practical strategies to overcome these hurdles and how to ensure compliance with upcoming regulations. We'll discuss this with Greiner Packaging. Furthermore, we'll also gain valuable insights from Switzerland's largest dairy company, Emmi, and they will share a first example on how to overcome the material gap with their innovative RPS cups. So with that, I'm very pleased to welcome our speakers today. I'd like to welcome Florian Aschermeier, who is Global Senior Expert for Sustainable Material Excellence at Greiner Packaging. And we also have Birte Dorenkamp, who is Head of R&D for Sustainable Packaging at Emmi. Before I hand over to our speakers, just a little bit of housekeeping. There are 15 minutes at the end of this webinar reserved for a Q&A. And using the chat facility, please post your questions in there and I'll put them to speakers at the end of the session. You can do this throughout the entire webinar and we'll try to get as many of your questions answered as possible. And if you have any technical questions or issues, please select the support button, which you'll see on the left-hand side of your screen. Without further ado, I'd like to hand over to you, Florian, to get us started with the presentation. Thank you.
Well, good afternoon. So I'm already having my eye a little bit on the viewer counter, which is already in 3 digits. So I have to really thank you already now for joining. And I hope you will have now a few good insights in this material gap and how we overcome it. So to start with, I would like to introduce briefly the company. So we are an Austrian-based company with the main focus on plastic packaging. We had last year around 900 million euros in revenue. We have around 5,000 employees and around 22 production sites. You can see it on the slide here. These small dots are our production sites and sales offices. So we have a focus on Central and Eastern Europe. Besides packaging, we also have a second business unit for technical parts, mostly OEM. But you can see here our main markets are for packaging and they are in the food industry. And you can see also a huge focus on dairy products. If you have a very short look to this pie chart, you can see that in this product categories, in these markets, there is a strong focus on polypropylene. So we are only rigid packaging manufacturer, and we have around 3/4 of our portfolio in polypropylene. But also polystyrene and PET, you can see here, are very important materials in those market segments. So we already heard it in our introduction from Liz that one of the key challenges and one of the key regulations or legal framework that is concerning our industry is the PPWR, which is the Packaging and Packaging Waste Regulation, which entered into force this year. And it's a quite huge and complex piece of legislation. You can see here, it's about waste reduction, it's about recyclable packaging, it's about the recycling content, which we speak about today, but it's also about packaging minimization and conformity assessment and many more. So what you have to keep in mind, even if we focus now on recycled content, not everything what we have is in, or what will be needed in the future is already in force now, and we also don't have everything written in the PPWR. There is a lot of pieces of secondary legislation, so-called delegated acts, which will influence us in the upcoming years. So with a focus on recycling content and PPWR requirements, we speak about Article 7 in this regulation. And this article is about mandatory recycling content in plastic packaging. And as I anticipated, those are not applied now. They will be applicable in 2030. Yeah. So we have now time to prepare. And those quotas that I will come to in a minute will increase in 2040. When we speak about mandatory recycling content, we speak only about post-consumer recycled plastics. We have currently in the regulation, let's say, openness for technology, so nothing for the moment is excluded, which means we speak about chemical and mechanical recycling here. And the quotas are, let's say, slightly different for different categories. You can see those 3 categories here on the slide. The first is contact sensitive, second is single-use beverage bottle, and the third is other packaging, which is mainly non-food packaging. And for our market segments that we are in the rigid food packaging, that would be in the very left category, contact sensitive, which also includes cosmetics, medicine, and feed packaging. So in this category, there are 2 different quotas. There is 30% post-consumer share for PET, which basically comes from the beverage bottles, as there is already the single-use plastics directive defining those quotas for the beverage bottles. And so the Commission took the same quota also for PET here. For everything which is not PET, so our main polymer, polypropylene, and polystyrene, we have a minimum recycling content of 10%. These quotas will be not applied per each item, but it will be more like an annual calculation for, let's say, plants of the brand owners who use the packaging, who fill the packaging. And this average calculation will be per packaging type and format, which is defined in the annex of the PPWR. And it will be per year. And I would like to really highlight here that that is already some kind of information, that's true, but the precise calculation logic will be defined more or less now, or is currently defined by the European Commission, and will be published by the end of 26. So after that, we know exactly how this will be calculated. Okay, so I talked already about mechanical and chemical recycling, and I think it's really good to have everybody on the same page. I assume most of you know it, but to have everybody on the same page, I would really like to explain you briefly the difference. So mechanical recycling, I think it's what every children might imagine when it comes to recycling. So there is some waste, and you turn that waste into new products by sorting, washing, grinding, applying decontamination to get rid of any, let's say, residues. And then it goes into like a granulation step where it's reheated, extruded again to some pellets. And those pellets are then the so-called post-consumer recycled material. And we use that as Greiner packaging to produce new products. Yeah. So only like reheating, let's say, is the main, operation here. For chemical recycling, it's a bit different. So it all starts again also with waste here, but it not necessarily need to be separately collected. So any type of feedstock suitable for the technology could be taken. And by applying also excessive heat and absence of oxygen, it turns, or this plastic mass turns into something like oil-like state. Some call it also a synthetic naphtha, which is naphtha is a fraction of crude oil, which can be directly fed into the petrochemical supply chain. So again, the waste is turned into like a oil-like state, so it goes more or less back the way that it was produced, and it goes into these huge facilities where the oil is turned into intermediates and back to polymers. And this fact means that you lose basically track of the individual molecules. So you don't know in the end which waste or which molecule, which was waste, is turned into which polymer and which molecules come from the crude oil. And that is why a so-called mass balance scheme is applied, where you physically mix your material in the supply chain. So basically, when the synthetic naphtha from the recycling and the crude oil naphtha is mixed, it's turned into monomers in this first step. And already there you have this so-called mass balance credit. So you really keep, or you have on your bookkeeping level the equivalence in the mass, and you keep that along the supply chain. So in the end, we as Greiner receive the same granulates as virgin, so it's the same quality. It also has food approval, and we keep track of the sustainable credits by this mass balance scheme. It's a third-party audit, so it's audited along the supply chain to keep track of this sustainable property. If you want to have an example, it's quite similar to green energy supply. What you get out of your electricity socket is all the time the same, depending where you put, let's say, the money in, the equivalence of the technology is, let's say, supported or funded, let's say. So that's the main differences. Okay, so I would like to start now after the introduction phase to give you really insights where we are standing. And I start with the status quo of recycling content at Greiner packaging. You can see on this slide that we have here again our three main polymers: polypropylene, PET, and polystyrene. And for polypropylene, again, speaking about chemical recycling, this is currently the only recycling option for PP with the direct food approval. So we are in our major plants ready to use this mass balance material. We have the third-party audit, and we already know how to handle the material. We had last year approximately, let's say a small 4-digit amount of tons of this material already processed to packaging. Let's call it the holy grail of recycling is still mechanical recycled polypropylene, which is currently under intensive development, and it will be one of the main focus points in the later slides of this presentation, so I keep it for the moment. PET, I think it's quite state of the art. Everybody knows the PET bottle recycling, bottle collection. So we decided at Greiner to integrate ourselves into the supply chain. We operate a recycling plant in Serbia, where we get collected bottle bales and we sort them for different qualities and for different colors. And we wash them and produce flakes, which will be then also transferred to our clients externally and also internal clients at Greiner Packaging. We also integrated ourselves in this second step of the waste recycling, which is the decontamination. So we receive the flakes, we decontaminate the flakes, and produce already a defined rPET sheet, which we use then in the second step for thermoforming lids and cups. And we have two of those lines, one in Northern Ireland, United Kingdom, and Czech Republic. Last but not least, polystyrene. This will be the second focus point of the later slides. To make it short for the moment, there is a proven food safety concept, which is called novel technology under the regulation 2022-1616. And we will start with lead clients to put this packaging on the market next year. I don't want to ruin the surprise, but you will see in the second half who this lead client might be. Okay, so you have now a bit of an overview how like the packaging industry stands with the recycling content. And yeah, we see when we look into 2030, and if you have a look on this right side bar chart, when we look into this year where the Packaging and Packaging Waste Directive Article 7 mandatory recycling content will be enforced, we see a huge demand, especially for these main polymers that we are in. And if you look to the second bar chart, you see figures from 21, which are very low compared to that demand. Here we have a factor of 5. And please, for the moment, don't pin me down on these exact figures. There are different studies which show slightly different figures. You can see here the Conversio study from Germany in 2023. But let's say in a sense of magnitude, or in the order of magnitude, the picture is quite the same. If it's the factor 4, 4.5, or 5, there is quite a huge difference between what we are using now and what we need in 2030. And for us, there are currently 3 main reasons for that. So one, very obvious, we have not 2030. It's now 2025, there are still 5 years. So you need to convince everybody in the industry, or also the brand owners, to start early. And yeah, at some point that works out, and some point that's quite hard for the moment, as it's not applicable today, but we need to have a nice ramp-up curve for 2030. The second challenge that we see is the low virgin prices that we currently have on the market. And whenever you have that situation, the recycling content, which is quite, let's say, intensive in terms of the effort you need to put in compared to virgin, which also comes from outside Europe. So you have here a quite tricky market situation for everybody in the recycling industry currently. And last but not least, especially when you look then to the polyolefins in this chart, there is a huge gap because there is a huge share of food contact materials or packaging, and we are lacking in the food approval of especially that. Yeah. So these are the main reasons for the gap, and in the upcoming slides, I would like to highlight how we could overcome them. So again, polypropylene is our main material. Polypropylene is for those markets that we're in the main material, and it's also the main challenge for food approval, and one of the first things we have to overcome to close the gap. So with that slide here, I would really like to go now into the details, how this path to food-approved mechanical RPP could look like. So in the end, it all starts with the waste stream. Yeah. So we need a high-quality waste stream, and we need a scalable waste stream. Usually, we speak about dual systems, separate collection of packaging items, and those need to be sorted with highly sophisticated, high quality sorting plants. And after that, what we already see is you need a second sorting step, which sorts for color, mainly white and transparent, but also sorts for food contact, let's say, applications in the waste stream, because this is one of the major requirements of the corresponding food contact legislation. So you really need investment in new advanced sorting technologies. If you have a sorted material with a high share of food contact material, speaking of more than 95 or even closer to 100% of food contact material, this usually compressed bales need to go into a washing facility at some point. And what we already know is we need hot washing to remove the residuals on the surface, and we will need some kind of de-inking or friction washing to remove the inks and adhesives and everything that is attached on a macro level to this waste stream or to this material. That's also a major requirement from the food contact legislation. After that, you usually already see really the quality of this flake material. You can smell it, you can see it, that there is a huge difference between the waste at the beginning. I have stood next to those material, and you can really, when you grab it, imagine that it turns into something you very really want to eat out of again. Yeah, but there is one more layer of safety. There is also the cleaning on the micro level. So whatever small residual molecules goes into the matrix of the polymer needs to be decontaminated. That's a major part and requirement of this food contact legislation, which is the 2022 1616 regulation. And without this approved process to that point, including the decontamination, you will not get the food approval. That's exactly the challenge that we need to overcome. If we have those material, it's then our challenge, and together with our clients, the challenge to create the demand that the, let's say, supply chain before, so let's call it the recycling supply chain, gets some investment security to scale the corresponding quantities, which again can close this gap that we see. I would like to go now with you one last level deeper into this food approval, because we speak, or I speak a lot about this cleaning on the micro level, about contaminants and decontamination. And I'm a consumer as well, so if you hear those terms, you really need to interpret this. You cannot leave it like that. So in Europe, we have the best and, let's say, most safe toxicological assessments and food safety criteria, which go, for example, way beyond the FDA in the US. And the concept itself is quite easy, so I would like to explain it to you. Everything in the background, which goes then more level deeper, I will spare for the moment, but I really want to give you these insights. So on the left side, you have the recycling, which is basically some kind of cleaning, if you want to simplify it, for those contaminants. And on the right side, there is the application. The application at some point forms a threshold. And the recycling or the cleaning needs to be that good that you are below those super sophisticated, highly safe thresholds. So what we need to do is we really need to look into the waste stream. We need to understand what is the worst case input contamination that we can imagine to find. So that's a lot about statistics. After that, if you know what you can expect, you need to test your decontamination equipment. You need to prove, let's say, how much percent of those contaminants can be removed. And with that, you know what is left over. So in the recycling PP, there is something in the worst case, there is something left over. And looking into the right side, we need to define the threshold. And you can define it by a so-called migration model. So you calculate how much of these residues from the polymer go into your foodstuff. And with the consumption behavior, you have what they call a exposure scenario, which is basically your toxicological threshold. And the left side, so the residuals in the PP, must be lower than this threshold. And believe me, every of this point has a lot of safety factors. So in the end, and it's basically the same approach that was used for PET, this is really highly food safe if you get this food approval, which looks very promising at the moment. Okay, let's have a small summary on PP. So I would really like to highlight the first challenge is the waste stream. We need to handle the complex waste stream of PP. This is very different to PET. If you sort the bottle, that's quite easy. If you sort from the packaging waste of PP, people throw in everything. So everything that is PP, you're able to find there. And a lot of things are out of PP, which are not packaging. So you really have to have a very, very good waste sorting to get rid of those stuff you don't want. And that brings me to the sorting. So we really need to have the AI sorting, object-based, to identify the PP food items. After that, we need highly sophisticated washing with the inking, getting rid of everything that is attached on the macro level. And we need the decontamination technology that can reduce the residues in the material to a safe level. And that's exactly currently the industry approach to close the gap. So exactly this R&D, this consortia projects, everything attached to that is currently ongoing, and Greiner Packaging is actively involved in that. And we already saw on the lab scale that this works. So we already put a cup on the table which has a very fine test results when it comes to this food approval and migration. But the whole process needs to be now transferred to a commercial relevant level, which gives, again, let's say, more demand on our side, which results into investment security back into the supply chain, which can reduce cost and close the gap when it comes to this commercialization of the material. I promised you not only to go into the details of polypropylene. So now I would like to go on with polystyrene and explain you a little bit the differences of the material. So let's start with the waste stream. Usually there are huge amount of items with polypropylene, which is different with polystyrene. So when we see things in the packaging waste which should not be in there for polystyrene, it's at many points, for example, a cloth hanger, a black cloth hanger, for example, which is quite easy to sort out because it is black, for example. Yeah, so that could be an example why it's more easy to handle polystyrene. So if you sort already for white polystyrene, which is quite basic in the first sorting step, that already results in very high quality and high food contact share. So the whole, let's say, waste stream topic is already successfully, let's say, reached for polystyrene. When it comes to washing, we have, let's say, slightly similar challenges with removing inks and removing adhesives and so on. But if you have a lower, let's say, complexity, that helps you here definitely as well. And last but not least, the decontamination. So without going into too many details, polystyrene from the inherent properties is a little bit more closer to PET, which helps in decontamination. So it's easier to reach the safe level. And polystyrene is also a so-called low migration polymer, which gives us one more advantage, which is written here in green. You can add an additional barrier layer of virgin polystyrene, so the whole thing is still monomaterial. So you can add an additional layer of virgin PS to even increase, let's say, these layers of safety. Again, here, same structure of the slides. I would like to really only highlight here what is now different. So the waste stream is analyzed for polystyrene. There has been huge industry projects with a very nice statistic over season and countries in Europe. So we know the worst case input contamination for decontamination equipment. And we also know that it does not need to be like a very, very sophisticated decontamination like for polypropylene, because it's a little bit easier to handle PS. And we also know on the application side that when we add a virgin layer on the, let's say, both sides, one on to the food contact side and one onto the outside, and like cover the recycling PS in the middle, that helps us to stay way below the toxicological thresholds similar to polypropylene. So you also have here this exposure scenario, and this really helps you a lot in achieving the food approval. So with that, I would really like to thank you for listening to my part. So we heard about the material gap, which is obvious to the high demand of PPWR. We heard about the main trigger factors, where the first one to overcome is the food approval to create demand. We heard for polypropylene that we are on the way, excessive R&D ongoing, we know what to do. For polystyrene, we already see here some solutions, and with that, we want to increase the demand. And with the demand increased, we want to secure more investments in the supply chain, having a nice ramp-up curve from now to 2030 to close the gap. And with that, I would like to hand over to Mrs. Birte Dornkamp from Emmi, who will show you now how especially this polystyrene project fits to the strategy of Emmi.
Thank you very much, Florian, and to Greiner for inviting us to this webinar. And welcome to all of you. Today, we deep dive a bit into the sustainable packaging strategy of Emmi and how we convert theory into practice. But first of all, a few words to our purpose. So we are the leading dairy company in Switzerland, and therefore it's clear that we are caring about our people, our consumers, and for sure about the planet. And that means that we together create best dairy moments for today and for generations to come. And for that reason, we decided that we want to become a role model in sustainability. But what does it mean exactly for packaging? So we have the target to achieve 100% recyclable plastic materials in our packaging. And for sure, also a recycled content, which is really high of 30%. And we go for material consumption per year. And the reason for that is that we know that unnecessary packaging is really not good for a sustainable planet, and we keep on focusing on reduction. In 24, we achieved already a 23% of recyclability in plastic and a 64% of overall, and the recycled rate is by 4%. And you may have the question why it is. So I think you saw the presentation before from Florian, how difficult it is to get into that, but we will get a big step forward this year because we changed our packaging HDPE bottles, and there was a question in the audience. We changed our HDPE bottles into PET, or we are transferring it at the moment, which means that we can use the recyclate from our own bottles and put them back into our bottles. So we have a closed loop from next year on, in the middle of 26, on PET bottles for milk. But we talk about PS today in the dairy sector, and the question is really why we still go with polystyrene when we know that there are some discussions about it. So first of all, our clear goal is circularity, because we believe the packaging is only consistent for the future when we use it circular. So when we have the ability not having waste, but having it as a kind of raw material in the future. So we have the target to achieve a 30% of recycled content in our packaging by 27. And to achieve this, we need to have recyclate. And you heard about the mechanical and restrictions and also about the chemical restrictions. So what we did is we are a founding member of the industry organization Recipac in Switzerland, which is in the starting point of the process, collecting waste or collecting packaging waste. And we are not only a founding member, but we also want to bring our packaging into their bag and taking then afterwards the recycled content out of it. And yogurt cups are one of the key drivers of packaging for us in Emmi Switzerland. And around 60% of these cups are in polystyrene. So why have we started the journey within polystyrene? As I said, we are a strong driver in sustainability, and traditionally PS cups were made from virgin material. And the reason to use polystyrene is mainly because of the very good stability, the good barrier properties, the sealing performance. And in addition, we have specific cups where you have 2 or 4 together, and we need to break them, or the consumer need to break them. And this is not possible with other materials in a very good way today. But on the other hand, we know that there are increasing external pressure due to the EU Green Deal, the PPWR, our own targets, but also retailers' demands. And there is a growing demand for recycled content. So we wanted to be one of first mover using them. And specifically to achieve also our personal goal to reduce fossil-based share and close the loop. One of the good things is that consumers and customers really love the current cup, which is the polystyrene cup with a paper wrap around, because it appeals very sustainable to them. And sometimes it happens that something appeals to the consumer as sustainable, but in fact it is not. And that in this case it is, which is great. And for sure, one other point is that we want to keep our current equipment. It doesn't make sense to change equipment which still works. this is also not sustainable. So the key point to go ahead with polystyrene for us is that it really perfectly suits to our dairy applications. It preserves the functionality, which is great. We have no functional compromises, but the most important thing is we keep food safety. And that was also one of the reasons why we've decided to go for an ABA structure, which means we still have a virgin layer outside, and inside we have the RPS. So it's like a double security, let's say. We do not maybe need it in a couple of years, but for the moment, we really want to be very clear and very secure, and that is the reason why we decided for that. And the good thing as well is that we have no optical or sensory quality issues or changes. We still can keep our thermoforming behavior as it is, and we can run it on our current lines without any problems. But we couldn't do that alone, that's for sure. So we built it a couple of years ago, like a group with other dairy producers. And to be very frank, circularity really only works through collaboration. That's very important. So we work together with our main competitors, but also with other cup manufacturers, and specifically with Greiner, who really supports us in this case, but also with recyclers. And we had a shared goal. We wanted to keep the polystyrene in the market, closing the loop and finding a technological feasible solution, which is food safe. So the second point was that we went into dialogue with our authorities and retailers. And now the first cup will come on the market in Q1 26 with recycled polystyrene. That will be in Q1 26 in the yogurt cup. And we are really proud because that was a big way going there. And as you can imagine, the journey has only started, because sustainability is not like a sprint, it's really a marathon. So thank you very much. And please feel free to ask your questions.
Yes, thank you very much, Bitte, and Florian as well, for sharing your insights today. And I really like your conclusion, Bitte, that it's a marathon and not a sprint. That's yeah, definitely very true. So yeah, we've now reached the Q&A section of this session. I can see we've already had many questions come through, but yeah, keep them coming. Even if we don't get to your question today, our speakers have said they're very happy to answer your questions individually later as well. So yeah, keep the questions coming, and if we don't cover them today, there'll be an opportunity to reach out to speakers, or they'll get in touch with you to answer it later. So yeah, the first question we've had in was, how does the limited availability of recycled material affect packaging costs and supply chain planning? Maybe one for you, Florian.
Thank you. Hopefully you can now see me again, because I had obviously some technical difficulties with the camera. So I have now a second one from above. Well, about the availability and cost and supply structure. So as you heard in my presentation, for some of the materials and for some recycling technologies, there is not even a supply chain now. So we have to really form it. And yeah, definitely you see that, for example, for chemical recycling, that there is also quite high costs currently. I think if we can, together with our clients, form demand, our supply chain can invest and this scaling should bring then costs down. And we already try to get involved with partners into this supply chain, which will also make the planning and, let's say, the access to the material more easy for us, which we will then be able to hand over to our clients. So yeah, we need to work on together to form that.
Yes, thank you, Florian. We have a question for Birte as well. Is there a reason why 60% of your cups are made from PS and not from PP? And how do you assess this step towards sustainability by using RPS in this cup?
Yeah, good question. I mean, I tried to answer it a bit already in the presentation. So one reason is really because we have the specific thing in Switzerland that we have 2 or 4 cups together, and we need to break them. And the best way to do that is with PS at the moment. There are some trials with other materials like PP, but it's not working the same way. And that is the main reason why we still think that from a consumer perspective, PS is a very good material. From our perspective, as I said, we try to get into mechanical recycling as much as we can, because we know the CO2 footprint from chemical recycling is not the same as with mechanical recycling. So it's always better if you can get a cup out of a cup. Yeah, and that is one of the reasons why we took the opportunity to go into polystyrol. And just to add, maybe especially in Switzerland, there is a lot of polystyrol still on the market, which give us here the ability to build this stream.
Yes, that makes a lot of sense. Thank you. Somebody else asked us, how can smaller companies cope with the material gap compared to larger players like Emmi? Maybe one for both of you.
If you want to start, Birte, I can also add a few sentences if you want.
Yeah, I mean, I think it's mainly about the strategy you have. You have to screen your packaging, and then you have to do like a risk analysis. I think it's pretty the same than in any other company. You can say you are maybe a bit stronger with suppliers because you have more volume. On the other hand, you need more volume. So when the volume is not available. So finally, I think it's pretty the same.
Yeah, I can also add from our point of view, I think it's also important to get involved, to contact your supplier, which is basically us, to express, let's say, your, let's say, interest into this pilot projects as well. And what we can do from our side is really also guiding you, right? If you express your demand, we can really make some projects and form, let's say, a ramp-up curve also with smaller clients for sure.
Right, thank you. Somebody else is asking us, how realistic are the EU's 2030 targets for recycled content in food packaging, given current material availability?
Should I jump in? Well, yeah, I mean, for us, definitely, that's quite the challenge, right? You saw the gap, and when you see that gap, you can think if this is even reachable, right? So the first argument I can only repeat. So we have to form the demand to really get the supply chain going. If in any case we ramp up this curve and still don't hit the target 2030, there is the opportunity from the Commission to lower quotas or also postpone or maybe don't enforce in that let's say hard sense. But every communication that we get from the EU Commission is that they are really pushing for those targets and also trying with the upcoming years to make it more easy for recyclers to supply. So I think whenever we do our best and get 1 or 2 more years for the 10%, everybody can be happy, but still there is not any argument to stop or to lose speed.
Absolutely.
And
Yes.
I can add 2 points. One point is the consumer. I think it's quite important that consumers really put the packaging back into these bags where you can collect plastics and don't throw it in the standard bin. That's very, very important thing. And that they put it right into it. So like if you have a paper wrapper around, you remove the paper wrapper, or that you remove the lid rather than just putting it as it is in the bin. It always helps. That's one point. The other point is really that loads of companies are overfilling the recycled quotes at the moment to get like a good image in the market, because maybe the products are not that healthy. And I think that could be also a kind of trigger that companies will be forced to use the amount they should use, that there is sufficient material available for the rest.
Thank you. And somebody else asked us, when is the ideal time to start implementing recycled content?
Yeah, you heard it. It's basically now. Yeah. So whatever is available, we need to start. And definitely for everything that is currently in still in the R&D phase, let's say we keep you updated, and as soon as it is available, also the right time is now, in the sense. Yeah. We need to have a ramp up curve. We don't need to wait. There is no possibility to jump to the quota at the end of 29.
Yeah, that makes a lot of sense. It's good not to get here complacent here at all, isn't it? Somebody else asked us, are there any particular regions or markets where the gap is more pronounced due to different collection or recycling infrastructure?
Well, if you really look into the supply chain, yes. I mean, if you look, for example, on some kind of heat map from Plastic Recyclers Europe Industry Association, you can see more recycling capacities in Central Europe, for example, Germany, Netherlands, also Spain, UK, Italy, and so on. There are countries who push more for sorting, recycling, and so on. But that was the aim, or is the aim, of the packaging waste regulation, to have here a regulation which is binding from the EU to all the member states. So we will see, let's say, differences, regional differences disappear also over the years. And if you look onto the output of this supply chain, the granulates itself, they are anyway distributed and consumed where they are needed. So I would not see a huge gap there. But from bottom up, the quantities, you can see some kind of heat map in Central Europe currently.
That makes sense. Thank you. And yeah, somebody else is asking us, how can companies balance the volatility of PCR pricing and limited availability with long-term sustainability commitments and supply chain strategy?
So that's maybe a question for me. This is mainly about partnerships. I think it's quite crucial. So that's what I said. It's a cooperation. So sustainability topic is not something which is owned by a company or whoever. It's really a general thing. And therefore, we have to change our mind that we have to work together. And we're doing that. So we have strong partnership, like with Greiner, for example, and we develop these things together. So they developed the technology, we committed to use it. And I think that's the way forward. And if we go like this, I don't see any issues, because then you will not get a partner who's saying in 2 months' time, oh, now you have to pay 50% more. That's not happening. That it gets more expensive, that is for sure. I mean, if you saw the presentation, how it works to get from a product back to a product, then for sure it's clear that it's more expensive. But this is the same, and that's the good thing from the PPWR. It's the same for all companies.
Yeah, levels the playing field, doesn't it? Somebody else asked us, what makes consistent material use in a plastic product across different brands challenging?
Good question. You can see half glass full or empty or full, I would say. So you can say there's no differentiation anymore, or you can say it's luckily we don't have to fight about different materials in the future because there will be only a few. So you have to be more clever. You have to have a really good product. You have to have a clear message, and I think consumers will in the future not get focused just by a picture or because the plastic cup looks so good in comparison to another, but they will really go deeper into it, understanding what are the ingredients of the product into this cup, and if the cup itself is sustainable, if the full package is sustainable. And I think companies who started like Emmi in the past, or even like Greiner, they will have a better standing than companies who jump on the train in 2090.
Yes, that sounds very likely, doesn't it? Another question we had in was when we talk about barriers, we usually refer to a functional barrier, but here you mentioned virgin PS as the barrier. Could you elaborate on that a bit? One for you, Florian, I think.
Yeah, I thought so. Well, that's a quite interesting question. So, honestly speaking, it is a functional barrier. So, if you can imagine of materials like glass or aluminum, usually they are considered as an absolute barrier. Yeah, so you don't have to think about a lot what is inside; it won't go outside. Functional means always that it is tailor-made for the function, and the function here is to reduce migration to a level where it is food safe in, let's say, the scope of the shelf life, with all the safety factors applied. So it is not the absolute barrier, it is a functional barrier. In the past, we saw, for example, oxygen barriers like EVOH for specific applications. Theoretically, I think EVOH would also work out, but it's quite hard to make a product where you have EVOH on two sides on the outside, because you need a lot of let's say adhesive layers, and you need an outside layer, and it can also, if you exceed a specific amount, be in conflict with recyclability. So it would make the product way more complicated than it should be, or it would be some kind of over engineering, as the virgin material already is hindering migration. And if you apply it in the proper way, it acts as this functional barrier where it is reducing the migration to a level where it is absolutely food safe during the shelf life. So
Thank
that's
you,
the main thing, yeah.
Great. I think we have got one more time for one more question before it's time to wrap things up. We had a question, which is a decontamination technology that you recommend for PP in order to accomplish the requirements for food applications?
Yeah, I think I also take that one. So I hope you understand I cannot not point at any company at the moment for that, but I can, let's see, elaborate a little bit on the physical principles behind. So for PET, usually it's a classical, let's say, solid contamination. So you put your PET flakes in some kind of vessel, and you have it by evaluated temperature for a specific time. You can also add negative pressure to get the chemicals out. And this process alone usually will not help you for polypropylene. You need a little bit more on that. So most of the providers here go into like a liquid state decontamination, which is basically in melt. Yeah. So you have, after your typical extrusion step, some kind of unit where you have increased surface area of the polymer melt. you also have negative pressure and you have some residence time. And there, with the elevated temperature, let's say in this melt, you get way more contaminants out. And depending on the supplier and your feedstock, it can also be that the final granulate is also put into the solid state decontamination afterwards for a second time. So it could be also combination. But that's basically what we mean when the PET standard is not fitting for PP. You usually need melt decontamination in the, let's say, liquid state of the polymer.
Great, thank you, Florian. So unfortunately, that's all we've got time for today. I've seen we've got lots of questions. We could probably go for another at least half an hour, but yeah, don't worry if we didn't get to your questions. Our speakers are very happy to answer your questions offline. So yeah, you should be able to get answers to your questions. I should also mention that this webinar will be available on demand within the next couple of days, and you'll be sent a link to access it in case you want to recap anything you've seen today. So yeah, that just leaves me to thank you, our speakers, Florian and Birte, today. Thank you very much for sharing your insights, and goodbye.